My name is Ivana Kruijff and I work at the German Research Center for Artificial Intelligence in Saarbrücken. And I work on talking robots. We work on language technology that makes it possible for people to either communicate with machines, or we look at communication between people and try to understand it. And now, with respect to, say, the work of CTIF, for us in some applications that we do, people equals responders. So we work on technology that should help support responders in what they do, either using robots and being able to communicate with them in a natural way, or, as I said, looking at how they communicate with one another, and we are trying to support this communication by processing the language that they use.
So you're talking both human language and also talking machine language, and the interaction between, or what when you say language, what do you mean?
By language, I mean human language. So I mean, we, for example, make recordings of communication in a team during a disaster response. And we try for our robotic system to really understand what's going on in the mission from what the team members, the human team members, say to each other. So we want to understand which tasks the team leader has assigned to whom, and when they report on progress of a task, then we want to understand what they actually said. Has the task been successfully completed? What information has been communicated to the team leader? Things like this.
And why is this research important to you personally? What are you trying to accomplish?
So I am generally interested in how language works, how communication between people works. So making a machine which tries to mimic that helps us to understand what's going on, because if you cannot model it, then you haven't understood what's going on. Does it make sense?
Kind of. So if we contextualize it from a fire rescue point of view, I know you've been working with robots in Italy, in earthquake zones. How does this apply in those situations?
Mm-hmm. So with the robots, there are kind of two lines that we try. On the one hand, we try to, let me start again.
Yeah, no problem.
Okay, so we currently study communication between the human responders in the team, so that we can understand what they say to each other and what is going on in the mission. And the long-term goal would be, as the robots are becoming more autonomous, one day they will be able to do some of the tasks that now the human operators have to teleoperate the robots to do. One day the vision is that they will be able to do these tasks on their own. The robots drive to certain places, take pictures. And then we would like to make it possible that then the robot can communicate back to the team leader in the same way or very similar way as the human now does.
So not a radio-controlled robot, but a robot that can respond to verbal commands.
That's right.
That can reason almost.
Yes, yeah, exactly. It will have to reason. So the team commander, like the team commander tells to the operator now, I want you to drive around in this area, I want you to explore this area and search for sources of hazard. So one day I want that the team leader gives such an instruction, such a task to the robot, and the robot can understand it and knows what it means to explore an area and search for hazard. What is a possible source of hazard? The robot needs to know this so it knows what it's looking for, And then, okay, it has to have the capability to visually or by other sensory means process the scene and identify such potential sources of hazard. It has to have a strategy for driving, let's say, systematically through the area. If it encounters obstacles, it has to be able to avoid them, but then continue in the systematic search. All these kind of things that nowadays the operator controls the robot to do this and looks through the camera of the robot for the interesting objects. One day, all this the robot should or could be able to do on its own.
And how did you come to apply your research in a rescue situation? Why is that your chosen field?
So we wanted to do research that is challenging, that we apply the algorithms that we use in challenging environments. And that's how we came to do things in search and rescue or in disaster response scenarios, because these environments are very complex, unpredictable, and dynamic. So you don't typically get this in an office environment, or you get it to some degree, but here it's like that's the biggest challenge that there is.
And how far you come with implementing it? Is it just on a studying point of view yet, or how far have you come with actually putting this into practice?
We have implemented prototypes, and we have put our language interpretation components in the context of an integrated end-to-end system and have tested them with end users. So we have trained end users to use our system, and they have carried out situated or staged operations, disaster response operations, and they have actually spoke to each other in normal sentences, and our system was able to understand what they were talking about, recognize what tasks a team leader gave to the operators, and recognize when the operator was reporting back about the status of the mission. Of course, I cannot say we can understand just about anything that they say. We have trained them to use, to some sense, restricted language. We trained them to use the language that at the moment our system is prepared to deal with. But it has worked reasonably well, of course. Yeah, plenty of room for improvement and extending the capabilities. But as a proof of concept, it was successful.
And this was done in an exercise, a practice situation then?
Yes, this was done in the context of a joint exercise where the research group and end users, so firefighters, got together. We trained them to use the system that we have built, and they have themselves prepared a scenario in which this exercise was carried out. And actually, in the context of our project, we have done these kind of exercises regular on a half-a-year basis. We got the whole team together and made always tests at various sites, in various conditions, varying scenarios, to test the system to see what additional capabilities should be developed.
And the Italian project, that was a real live situation. Can you talk about that?
We had, over the course of the last 8 years, or more concretely in 2012 and in 2016, we had real deployments after earthquakes in Italy. In 2012, it was in the Emilia-Romagna region in Mirandola, where there was an earthquake which very much destroyed the village of Mirandola, and we were there with the Vigili del Fuoco, the Italian fire brigade, and we used the ground robot to drive inside a partly demolished church, the San Francesco Cathedral, and they wanted to see the status of certain icons and other artifacts in the church. And we used a UAV, so a drone, to drive around the tower, which was statically damaged, and they wanted to examine the cracks from closer by. So that was already in 2012. And then in 2016, there was an earthquake in central Italy, in Amatrice. And there, again, they asked us. This time, we got the request, and they wanted us to be on the spot within 48 hours. So that was kind of a real challenge for a research project team. So that was kind of one part of the test, whether this is actually possible. So we managed to be there on time with our equipment, and then we had a one-day mission. And this time, the goal of the mission was to collect data of 2 different churches, again, which have been severely damaged during the earthquake. And the task was to collect data and build or construct high accuracy 3D textured models of the churches. They wanted to use these models for making static assessment, for planning shoring operations. So that's what we did. So this mission was somewhat different. In Mirandola, the research team and the firefighters worked very closely during the mission. It was kind of a very dynamic operation where the firefighters were, so it was the researchers driving the robots mostly, but the firefighters were saying, oh, go there, drive here, we want to see this. In Amatrice, it was more, we were there with a team of 10, and they wanted to have these models. So of course, they provided the logistics and everything, but we were kind of a team with a task, and we were operating the robots and collecting the data, and afterwards we gave them the models. So that was more kind of an independent operation, if you want. So that there's a kind of there was a difference between these 2 missions in how close the cooperation between us and the fire brigade was during the mission. Which is kind of interesting we are studying the teamwork in such a complex human-robot team. So these are 2 distinct modes of teamwork in these settings. So that's quite interesting, and influences the communication between the researchers and the fire brigade team members.
So why CTF? What brought you to CTF, and specifically the Commission for Extrication and New Technology?
The Commission has discovered our work on human-robot teaming and found it interesting and wanted to incorporate this as one of the themes with which they are occupied. So the first involvement was that I was invited to give a lecture about what we have done in the project, and then they engaged me in the commission as an external expert on human-robot interaction. And then that's how I try to contribute.
And what does CTF mean to you? It's a little bit different. That question is a little bit different from you, maybe for somebody else, but because of how you brought in. But how do you see the organization? What does it mean to you?
Mm-hmm. For me, CTF is a door to end-user organizations, to the practitioners. For me, it's a great platform or a great opportunity to contact many different end users, many different first responders, and I see CTIF as a having great potential for exchange of experience, exchange of expertise, people sharing what they have found out, and for me, it's really very interesting to have the opportunity to see first responders reporting to each other what they have done and what concerns they have when they carry out missions. So I always listen for topics where maybe the kind of technologies that we are developing could be put into practical use.
And there's also some language barriers. There's many different languages and varying degrees of proficiency in English, and some commissions are operating in German or French. So maybe that's not a problem for you, because that's your type of challenge.
When they speak the languages that I also speak, then it's not a problem. But I see that as also an interesting potential theme where language technology could contribute, because CTIF members will always have this issue of having their local languages and each first responder wanting to share their experience in their language, whereas the others would need it translated. And we have, and actually I come from a department which specializes in multilingual technologies. We do machine translation, or my colleagues do machine translation. So that's also one area where I can see that we could potentially help to look into automatic translation of the mission documentations, for example, or the experience reports that are created, to make them accessible in different languages.
So can the robots actually operate in a multilingual environment as well?
We can make that happen. So far, what we have developed, these prototypes that we have developed, we have done it for English and for German separately. So these are systems that follow the same principles but implemented separately. Given sufficient resources, we can develop this for different languages. And if one would want to implement this on a larger scale, then it would be interesting to seriously look into which parts of the system can be shared across the languages and where the language-specific parts are.
And so what's the next step? What are you passionate about as your next step?
The current work that we do is still very much the next step. So I really want to get there, that we are able to follow the progress of a mission based on what the human team members communicate to each other, either through speech or through graphical user interfaces. So combine these sources of information and have the robot or any software agent be able to proactively support by providing some information or by suggesting some decisions that could be made to really benefit from the understanding of what's going on in the mission.
And so to what degree can you call these robots intelligent now, and what is the goal for their intelligence level? Is it like a true AI, or what we see in the movies, or what's the your vision for that?
Mm-hmm. Right now, as far as the language processing is there is not yet that much intelligence. With time, it will grow. And it also depends on what data we have available. As you probably know, building AI systems today is very often seen as building systems that are based on so-called deep learning, so neural networks. And these need relatively big amounts of data to learn anything. The systems we have developed so far are not based on neural networks. They are rule-based systems. So we have, based on what we have seen, programmed some rules how the system should interpret things and react to them, which is a reliable form of artificial intelligence, because you know how the system is going to react because you program the rules. But your rules only cover the space that you have programmed them to cover. If something else happens, then you don't have any reaction. So that's a bit the difference.
So in a sense, it's there's no risk that this robot start making its own decisions, but it's also a risk that it runs out of parameters and then it cannot make any decisions.
Yeah, that's the right way to put it. And now I am talking about the language components. In other parts of the robotic system, so the vision processing or the planning of the trajectories, machine learning has been used in those components.
And neural.
Also.
Yeah.
Also.
So what drives you? What's your passion about this? Why do you do it?
I hope I'm able to help. I would really love it when our technology is actually able to help the first responders to become safer or to do things that they previously that they otherwise could not do. So go somewhere into a situation where they otherwise couldn't. It probably is not the language part that will make that possible. It's more the actual robotic part. But maybe the working safer and maybe working more effectively, maybe the language part can also make a little contribution there.